And with that, I'd like to introduce our first speaker of the day, and our first speaker is Rex Black, with 35 years of software and system engineering experience. Rex Black is president of RBCS, his own company. He's a testing leader, providing consulting, training, and expert services. The company has over 100 clients on 6 continents, spanning all areas of software and system development, from embedded systems to gaming software to banking and insurance, and also pharmaceuticals and defense systems. He has worked with clients from small startups to Fortune 20 global companies. He has experience helping clients apply testing best practices in a wide variety of development life cycles, and that includes Kanban, Scrum, DevOps, Waterfall, and Spiral. Also, Rex is a prolific author. He has written 13 books, and he's just finishing his 14th, I was told. And he wrote numerous articles over the last 20 years. He is past president of the ISTQB and of the ASTQB, a co-author of many of the ISTQB syllabi, and chair of the Agile Working Group, the Advanced Test Manager Working Group, and the Expert Test Manager Working Group. Not many people know that Rex has spoken on all continents. The only one missing is Antarctica, and apparently this is because the penguins didn't have enough budget to have him. But we do. Please have a warm hand, Rex Black.
Thank you, Raphael. Don't get me wrong, I love penguins, but I just can't go if they can't have me come, you know, so good morning. Thanks for having me here. Beautiful city. It's my second time here. Got to go down and see the dragon. Unfortunately, the dragon was off. Apparently, he only blows fire at night. Is that right? Or does he not blow fire anymore because that's like contributed to global warming? But the last time I was here, he was like, I was standing there and didn't know that this was going to happen, and this huge burst of flame came out of him, and it was quite exciting. So, what I'm here to talk about is not penguins or dragons, but non-graphical user interface, or GUI, test automation. Now, how many of you have experience doing automation strictly through the graphical user interface? And give me a show of hands here. Okay, how about through interfaces other than the graphical user interface? Okay, and some of you know automation experience, I guess, yeah, okay. So, sometimes there is this idea that if you're going to test, whether automated or manually, it needs to be the way the user is going to use the software. This is an idea that sort of gained currency back in the 1990s. And it's my opinion that that was basically a wrong turn for our industry, testing, software testing. That this idea that if you're not testing it the way the user is going to use it, you're not actually testing it. There's a great marketing campaign, I guess marketing slogan, for companies that made graphical user interface test automation tools. Apologies to anybody from such companies that are here in the room. But it ignores the fact that really you can attack the software at any interface, at least if it's architected properly, and extrapolate from that testing at those interfaces how it is going to behave ultimately at the graphical user interface. Now, you might say, like, what do I have against testing through a graphical user interface? Well, it's certainly nothing if it's manual. But when it's automated, I think that trying to automate through graphical user interfaces exacerbates some of the problems that we tend to have with test automation. And, you know, just to be clear, test automation is an inherently highly risky proposition. I work with clients, as Raphael mentioned, around the world, do a lot of consulting work, and pretty much every one of my clients that has done test automation has a sad story to tell about test automation. It's just kind of like romance. Right? Everybody's gotten a broken heart at some point or another, right? So test automation has broken all of my clients' hearts at one time or another. And sometimes it's because it was being done through a graphical user interface. Sometimes people think, oh, I have to automate through the graphical user interface. But in fact, I've seen automation successfully done through command line interfaces, through APIs, application programming interfaces, through the data layer, and through network services. And I'm going to show you a couple examples here, 2 case studies going through the network services layer and through the data layer, just so you have a better idea of what specifically I'm talking about. Both of these examples that I'm going to show you were built using flexible and maintainable keyword-driven architectures. Now, a lot of times when people think of keyword-driven, they think, oh, well, that's some concept that was invented in the late 1990s specifically for maintainable graphical user interface automation. And in fact, both of the examples that I'm going to show you are not graphical user interface, and one of them well predates the 1990s graphical user interface automation tools. Okay? All right, so any of you familiar with this movie? Zombie fans? Walking Dead, you guys don't get Walking Dead here? No? No? Okay, well, you're familiar with this. There is this thing called zombie movies, right? You're familiar with zombie movies? So anyway, this is the original here zombie movie, Dawn of the Dead, and so here all these zombies are bursting into the elevator in the shopping mall, and they're basically about to eat somebody. Pretty terrifying experience for said somebody. None of you have seen this movie, huh? This really makes me a dinosaur. I saw this movie in a drive-in theater. There might have been beer involved, but I'm neither going to confirm nor deny that. So what are some of the things that lead to these sort of zombie apocalypses in test automation, these broken hearts that I was talking about? So one of the problems that you can have, and this can happen with any kind of testing, manual or automated, is the false positive. All right, so the test result comes back, it does not match the expected result, and you say, oh, well, that's wrong, right? There must be a bug. But then you dig into it and you find out, well, no, actually, the reason that we had this mismatch is because the data was set up incorrectly, or the expected result was incorrect, or there's some minor difference between the actual result and the expected result, but that minor difference is explainable. It's correct behavior. And so, for example, if the date changes on a screen, right, so if it's displaying today's date, and the expected result has the date on which the screen was originally captured, well, of course, that's going to be prior to that, right? So that's a simple example of how that happens, these false positives. And that example that I just gave you is sort of the classic example of the mistake that people make with graphical user interface automation when they're first starting to do it. And that's a pretty basic one, and it's pretty easy to fix, but there are a number of other fairly subtle types of problems that occur. And pretty much all of my clients that have done test automation through the graphical user interface can tell stories about high false positive rates. I've had clients tell me that they've had false positive rates up in the 40 and 50% range. Now think about that. 40 to 50% false positives? Where's your return on investment for automation if half of the time, for half of the tests that you run, you have to go in and manually investigate whether there's really a problem? Right? Is that actually helping you? Now, I'm not saying that testing a user interfaces other than the graphical user interface magically makes false positives disappear. I certainly have clients that have seen significant issues with false positives when they're testing at a non-graphical user interface approach. But the main horror stories that I've heard about false positives typically involve automated through the graphical user interface. Now, the other thing that tends to be a little bit more invisible from a problem point of view, but is still a big problem, is the false negative. So if you're not familiar with that term, false negative is referring to a situation where the test runs, the automated test runs, or manual test, and we decide, either we as manual testers running it or the tool that's running the automated test decides that the expected result and the actual result are the same, and the test is marked as passed. But in reality, there was some sort of significant problem that just was undetected for some reason. Now, with manual tests, that tends to be a matter of the tester not being adequately attentive. They miss some important detail. With automated tests, what can happen, especially like with graphical user interface automated tests, you can get a false negative when you tell the tool, hey, ignore this part of the screen, like the date. You say, okay, ignore that little field over there is going to have today's date on it. Ignore that because that's going to change. So that makes sense, right? Except that when the test runs, what comes up in that field is not today's date, say. It's got some kind of garbage, right? Or it's today's date displayed in Chinese characters or something like that. Now the tool won't see that, will it? Because I told it, ignore that. Yeah? So that can be a significant issue where with graphical user interface that the tool is looking for some specific things on the screen. It sees those things, but it doesn't look at other parts of the screen which are, very problematic. And again, this is something that I've heard plenty of horror stories from clients about of, 5, 10, 15% false negative rates. Now you might say, how did they know? Right? How did they know? I mean, because the tests were passing and they looked at it. Well, what happens is, of course, that the tests don't detect the defects, but that doesn't mean that the customers and end users won't see them, yes? So what happens is that they start seeing field reports coming back, and they're like going, well, we tested that. And then they manually audit their automated tests, and they find out, oops, that was happening right in front of our eyes, but we weren't looking at it, we were using the tool. You see what I mean? So this can be a fairly significant issue because obviously false positives, while they reduce test efficiency, are manageable and don't have an impact on the effectiveness of testing in the sense of our ability to detect defects. That being one of the major objectives of testing typically, detection of defects, right? But the false negative, of course, directly gets at the issue of the effectiveness of testing with respect to defect detection. Now, the other thing that we can get with automation is what's often referred to as the flaky test. You guys familiar with that term, flaky test? It's not a test that's made out of croissant, okay? It's not flaky like a croissant. It's flaky like a person is flaky, right? Unreliable, yeah? It's the unreliable test. So the classic example here is you run your automated tests, and you see that some of the automated tests have failed. So you rerun those tests specifically, and now they pass. And you have to ask yourself, should I feel better or worse? Can I believe the results of my tests? Well, no. And this can happen for a number of reasons. And my clients that are using graphical user interface automation have a number of stories to tell about this. Timing can be a major issue. And people that do graphical user interface-based testing, there's this sort of horror stories around use of sleep functions, for example, to get to wait for something to happen. How long should you wait? And so, you know, having these automated tests that are flaky, again, this is going to require a significant amount of human effort going in and, you know, looking at it, trying what's going on here. And sometimes you just come up with this decision. These tests simply are not automatable in any sort of viable fashion, right? We can automate them, but we can't solve the underlying flakiness of the result. We're never going to be able to solve that problem. And I had a client, that invested certainly thousands and thousands of person hours in building out automated tests. And they can basically be broken down into two groups. And one of those groups, consisting of on the order of 10,000 automated tests, ultimately had to be abandoned because they simply decided there's no way to deal with this flaky test problem. And they were consuming huge amounts of time going in and trying to get to the bottom of this in a sort of debugging mode. Now, again, I'm not saying that this only happens with graphical user interface automation, because it doesn't. I've had clients tell me stories about this happening with other kinds of automation through other interfaces, but it happens more frequently with graphical user interface automation than with other approaches. Now, another thing that can really afflict us in test automation is the unreliable or incomplete test oracle. Now, you all know what I'm talking about when I say test oracle, right? The thing that we can refer to determine the expected result of a test. So let me give you an example of this that one of my clients told me about, a test oracle problem. This client makes high-frequency trading software for stock investment organizations, trading companies. And the idea of this application, this system that they build, is to try to optimize the profit associated with these trades. Naturally enough, right? You want to buy or sell shares very quickly, and what you're trying to do is make money, aren't you? It's not that you're not like collecting stock certificates to hang on your wall. Yeah? You're trying to make money. Okay, so we can say that in any given trade, if the trade makes money, then that's good, right? But does that necessarily mean that if you're running a test and the result comes back that the trade is profitable, does that mean that the application actually passed? That it passed that test? No, not necessarily, because the point of the application is not just to make some money, it's to make the most money possible. It's to time the trade such that it hits the exact right point in time to maximize the amount of money that can be made, taking advantage of a difference between the bid and sell price. Now, how do you know? How do you know that you've made the maximum? Of course, the program is designed to try to achieve that, and the program comes back and says, yep, this is how much money we made, $1,000 or $10,000 or $100,000 on that trade. How do we know that we couldn't have made $2,000, $20,000, $200,000? You see my point? What's our oracle there? So, in these sort of situations, you may get tossed back on having to rely on what's called a partial oracle, which is where you say, well, you know, any time the trade results in a return on investment that's less than 1%, or certainly it's negative, then we're going to call that test a fail, and we're going to take a closer look at it. But then that, of course, gets us back into the realm of false positives, potentially, but we're also in the realm of false negatives. You see that? Because we might say this test passed, Well, did it really? Did this actually result in the optimal outcome, the maximum amount of profit that could be obtained from the trade? Now, this is going to be, this test oracle problem is going to be a bigger and bigger and bigger problem for us in test automation, software testing, as time goes by. You're testing, I get, you haven't seen Dawn of the Dead, so I'm probably the real dinosaur here. So now I'm going to bring up like the dinosaurs. If you think back to testing a mainframe application that runs in a data center that does, banking, there's clear right and wrong answers there, yeah? There are accounting rules that determine how that works, and there are banking regulations that determine how that works. The oracles are available, they're unambiguous, there are clearly defined right answers, and when you're running the test, you can compare against that. Okay? And there was this famous quote from somebody in the late 1940s, I believe, or early 1950s. I can't remember whether this was the head of IBM, Watson, or somebody else, but made some sort of comment about why would the world ever need more than 100 computers, right? Think forward, like we had 32-bit IP addresses and we ran out of IP addresses, right? Yeah. Not only do we have more than 100 computers, and we've got billions of IP addresses, right? Everything's going to have an IP address. Your refrigerator, yeah, and your refrigerator is going to talk to some piece of software in the grocery store and say, "Order me this." Now, if you come home from work and there's like 50 liters of milk and an entire frozen dead pig in your refrigerator, that's probably a bug, right? But, my point is, we're getting to this extreme interoperability point. Everything's going to talk to everything else. What's your oracle for that? Yeah? Self-driving car. I mean, obviously we can say if it doesn't kill anybody, that's good. Yeah? But, I mean, that's a pretty low bar, right? What does correct behavior look like in the self-driving car? Above and beyond, doesn't break any traffic rules and doesn't result in any injuries or fatalities. So this is something that, regardless of the interface that you're automating through, I'd really encourage you to think a lot about because this is, I think, going to be a bigger and bigger and bigger problem for us. What does correct look like? Now, coming back to this issue of the graphical user interfaces, one particular issue that comes up over and over again with my clients that try to automate through a GUI is the GUI broke my tests because we changed the GUI. And you hear stories about people saying, testers saying, well, don't change the interface because it's going to break my automated tests. And that's like, well, wait a minute. We're not allowed to improve the usability and functionality of the application because we automated it? Aren't we supposed to be in the quality business, not the impeding quality business? Yeah? So this is one of the particular faults of graphical user interface automation, is being an obstacle to changes to the graphical user interface. And I get that there are architectures that are designed to try to help with that, but my clients have lots of horror stories about, whoops, the UI changed or something else changed, and the test maintenance costs just went through the roof. So, for example, I was working with a client doing an assessment a number of years ago, and they had brought in this outside group of a testing service provider, a vendor, claimed to have expertise in automation. Oh yeah, we're real experts at using whatever tool it was. It was a commercial graphical user interface tool. And so I go and I talk to the lead, the tech lead, who's in charge of this automation effort, and I said, okay, so how many new tests do you and your team, he had like 5 people working there, plus himself, how many tests do you and your team build every month? He said, not too many. I'm like, give me a number. How many is not too many? He said, well, on a good month, it could be, 10, 50 tests. On a bad month, none. I said, well, even on a good month, that's a pretty small number of new tests to build when we're talking about 6 people. What are you doing? I said, well, mostly we're maintaining tests we've already built. Now, this organization had 100 applications in their data center, and their goal was to use this automation to regression test all 100 applications. So I said, you're maintaining tests you've already built. How many applications do you have tests for? He said, at this point, only 1. I said, of all the tests that you intend to automate for that one application, what percentage would you say that you've automated? He said, maybe 10 or 15%. Do the math there, right? This is a complete and abject failure, yes, by any measurement. Haven't even gotten through 100% of automating one of the applications that they wanted to automate, right, out of the 100. So they're not even at 1%. So I go back to my sponsor, the point of contact there, and I ask him, what is the return on investment for your automation? And he gave me that look that clients give me when I ask them a question that they know they should know the answer to, especially because his boss, the CIO, might very well ask him that question, and then they don't know the answer. Right? They kind of look like, oh no, that's the question I really should be able to answer, and I don't know the answer. And so I let him kind of hang there for a minute. Not a minute, it was probably just a second or so, but you know how that like feels when somebody asks you a question and you get that sinking feeling, and even though it may not go on very long, it feels like hours, right? So I let him hang for that what probably felt to him like minutes, but it was like a second. I said, okay, look, I made a bad joke. Okay, I don't know what your ROI for your test automation is either, but I do know a couple things about it. It has a minus sign in front of it, and it has a lot of numbers after it before you get to the decimal point, okay? I said the thing that you need to do right now is fire that whole organization, that vendor, that if they are actually experts in automation, they know that they're ripping you off. And if they don't know that they're ripping you off, they are not experts in test automation, okay? So definitely, you've got to know what your test maintenance costs are in order to figure out what your ROI is for your automation. And graphical user interface test automation has a horrible track record with respect to getting a positive ROI. Now, if you're thinking, wow, how do I calculate this ROI? I'm not going to get into this here. I am doing a free webinar, I think in November. So if you want to catch that, it's a short little 20-minute webinar on how to calculate your test ROI. So if you don't know how to do that, feel free to sign up at the website as you see down on the screen, rbcs-us.com. You can find the free webinars and tune in, and I'll explain that. But definitely know your ROI. Now, the other thing that can really hurt you in automation is the licensing costs associated with commercial tools. Now, my favorite story here, anybody here work for HP? And I'm going to tell a story, a Mercury tool set story, and I don't want you throwing eggs at me. HP, their GUI tool, which is now UFT, at one time was called WinRunner, and HP, Mercury, which then owned it, this was before HP bought it, Mercury had been promising their customers that they were going to introduce support for testing SAP, you know SAP, the enterprise tool, and they were like saying, yeah, we're getting to SAP real soon now. And then they introduced it, support for testing SAP, and they said, and oh, by the way, this is an optional add-on, and this is going to cost you $1 bazillion to enhance your license to get this, right? So, I've had clients tell me stories like this of like all of a sudden getting slapped in the face with these licensing fees and these add-on fees. It's like, where did that come from? Now, I love the fact that that approach to basically billing their clients if the client watched the sunset and was made happy by it, right? That kind of approach to tool licensing backfired because a bunch of people in reaction to that kind of thing went off and created Selenium. Yeah, and you all know why Selenium is called Selenium, don't you? No? Well, so there's mercury, and mercury is what? It's a liquid metal, and it is poisonous. Yeah. What's the cure for mercury poisoning? Selenium. So, hence the name. So, this is a real problem. The licensing fees are so high that it just kills the effort, and graphical user interface automation has been infamous for this. Okay, so let's talk a little bit about automation and how to approach it just in general, and then I'm going to go into my 2 case studies here. So the best practice is to try to modularize the automation so that when changes happen, it does not totally break our automated tests. And what's arisen is this idea of keyword-driven test design. So the keywords are going to represent some sort of thing that one can do with the system. So the thing that one can do typically corresponds to a use case, though the use case can vary in terms of its size. Now, this is going to allow, this definition of the keywords is going to allow the testers, the test analysts, the non-technical and business-focused testers to write their tests in a human way of writing it rather than code, okay? Now, the tests, though, do have to be concrete. The tests have to be written in such a way that they are explicit about, okay, take this input and put it into this field, and you should see this result. They can't be logical tests. But certainly much easier because now we've separated the duties of who's writing the automated scripts from who's writing the tests that use those scripts. And again, in the 2 case studies, I'll show you how we exploited that keyword-driven architecture in the 2 systems test systems that we built. Now, the maintainability of tests that are built this way has proven over time to typically be higher, though certainly it is possible to get eaten by some of the zombies that I was just talking about, even if you're using keyword-driven architecture. I'm sure many of you in this room can cite a horror story of we did everything right from a keyword-driven architecture point of view, but we forgot about X, and X jumped in through the opening elevator door and ate us, right, and killed our automation effort like about half of automations do. So what's the process for building this system? So we have technical testers or technical test analysts, or what are sometimes called SDETs. You guys familiar with that term? SDET, Software Development Engineer and Test. Do you hear that over here? Yeah, kind of, okay. So they're going to build using some sort of scripting program or scripting system, which I'll address when I show you the case studies, this automated system. And it is a system. It's software that's designed specifically to test another piece of software. Which, if you think about it, is a really complex thing, right? Because interactive software that's designed to interact with a person, when it gets lost, it can basically appeal to the user, right? Help, I don't know what to do next. Please tell me what to do next, right? You may not think of it that way, but think about your interaction with software. When something unexpected happens, you're using your phone or you're using your PC, something unexpected happens, what does the app do? The app asks you, what should I do next, doesn't it? It doesn't just continue on, Now, if we're trying to automate tests, notice that that very behavior, which we would consider, if properly implemented, to be good behavior in an app, a phone app, for example, mobile app, is horrible for something that does testing for us. Because that's going to kill our ROI, isn't it? If it's in the middle of running 10,000 tests and it gets to test 5,000 and then it gets stuck and it goes, oh, help, I'm lost, what do I do next? Then it just sits there until the tester shows up, right? Now, if the tester has to babysit the automated tests while they're running, where's your ROI? This is something that people don't understand. I have clients all the time that tell me about this classic failure of automation. I'm like, well, how are you doing your automation? And the client will say, well, we hired these 2 kids straight out of college. They got computer science degrees, and they're really, really smart. I'm like, yep, there we go again. That's the beginning of one of these sad automation stories. You may not know it yet, but that's going to have a sad ending because you're asking them to build a system that has to be able to do something that your own software can't do, which is run unattended for extended periods of time and be able to figure out how to extricate itself from a ditch if it gets thrown into one. They don't know how to do that. 2 kids straight out of college, they don't know how to do that, right? You got to have some serious experience with this stuff to be able to know how to do it. So, one thing to take out of this talk, if nothing else, if you're going to go off and you're going to build an automated test system, make sure you've got somebody who's got 5+ years of test automation experience who's the tech lead on that. Because there are so many ways to screw this up. And I've heard so many horror stories from my clients that you really need to have seen how these things go wrong a few times to be able to avoid it. Now, what should these people be building? Well, the typical components of a keyword-driven system would have something like a front end that basically hides all the complexity from the people who are going to build the tests using the keywords. I've seen these be fairly sophisticated, I've seen them be rather rudimentary, but the more sophisticated ones do make it easier for people to build and maintain the tests. Each keyword is typically going to correspond to a single script, and again, I'll show you a couple examples of that. And then we have a execution virtual machine here, which is what actually runs the tests, and I'll show you that as well when we go through the examples. And we also need some sort of ability to select tests to run. And this needs to be constructed in a friendly way as well, because you don't want the tester to be confronted with this situation where it's like, I test everything or I test nothing. Or I test everything or I test a single test. Tester ought to be able to select an arbitrary set or subset of tests to run out of the enormous set of tests that have been automated. That needs to be one of your requirements. And oh, by the way, if you set off on this little adventure of building your automated test system and you don't have well-defined requirements, shame on you, okay? As testers, we should know better, right? But I see this happen a lot, and this is another one of these things that kills automation efforts. It's like a solution in search of a problem. We built this cool thing and it does all this automation. I'm like, why did you build it? Well, because blah, blah, blah. And I'm like, no, what exactly were your requirements? What problem specifically were you trying to solve? What constraints did you have to deal with? Oh, I don't know, but it's really cool. And that reminds me of, here again, I'm going to be like Mr. Dinosaur, right? T-Rex. Any of you ever see the movie Fantasia? Okay, there's a famous scene in Fantasia. You can definitely find this on YouTube. It's the dancing mops and brooms scene. Okay, so the junior sorcerer figures out how to make the mops and the brooms dance around because the senior sorcerer told him, clean up the magic studio while I'm gone. Right? And so rather than push the brooms around himself, he gets the mops and the brooms to dance, and chaos ensues. All right? And this is what happens a lot of times when people set out and it's like, I can build this really cool thing. Yeah, you can make the mops and the brooms dance, but you're not actually cleaning the room. You're just making a bigger mess. Okay? And keep in mind if you're going to do this, when you set up your keyword-driven system, you're gonna want to add more keywords. Yeah. So you got to build it in a way that it's extensible, and extensible in a reasonable fashion. I've heard a story from a large company, and this was given in a publicly delivered speech here in Europe, so I can mention the name. This was Microsoft. They had a problem in one of their groups where basically every time they added some new piece of functionality, they had this whiz-bang way of automating tests. So they just created a bunch of automated tests and threw it in their automation bucket. And they're like, yeah, every time we do a nightly build, we rerun all the tests. Okay? You know what happened? They ran out of seconds in a day, basically. Because what happened was the number of tests grew and grew and grew, and every single test was very fast, but eventually, there's a finite amount of time consumed by the tests. So eventually they're like, oh, well, we have to split our tests and have them run in parallel on 2 systems. They continued to throw new tests into the bucket. And guess what? Then they had to have 3 separate systems. And then 4. Right? And now they're spending all of this money creating and supporting this test hardware. And they've got millions of automated tests, and they've got no way of knowing which tests cover what. Because they had just assumed they could always just throw them in the bucket and run them again. So think about this. The system is going to grow and change. Think about how you're going to keep it healthy. And healthy means like not consuming infinite resources. Okay, so as I said, I'm going to show you some examples of this, of these keywords, instructions, test data, and so forth that compose the test cases. As I said, one of the main advantages here is that we have separated out the duties of building the scripts and building the tests. So we are taking advantage of specialization. Now, specialization has kind of become a dirty word in recent years. If you go back and read one of the original books on Scrum, there's a comment in it where the author basically mocks this idea of specialization, and he comes up and says, well, someone can be a designer and an architect and a programmer and a tester, and there's no need for specialization. And it was kind of funny that I remember when I read that, I'm like, God, where have I heard that before? And I don't know that this was on purpose or not, but it turns out that Karl Marx, you guys remember him? He's a real dinosaur, yeah? Karl Marx, in the Communist Manifesto, made a comment about somebody being a farmer in the morning and a horseman in the afternoon, I think, and then an art critic at night under communism. Communism was going to create this great world where there wasn't going to be any need for anybody to have any roles, and everybody got to do whatever they wanted to do. Well, you guys may have a little bit of an opinion on how well that experiment worked out. Well, first-hand experience with that. And I don't think that this idea of anybody can do anything is going to work out too well in software engineering either. So hopefully we start to regain our sanity and realize, yes, there is actually a role for specialization. So definitely you want to separate those duties of who's automating and who's creating the tests that use the automation. Now, the creation of these tests have to be integrated into the lifecycle properly. Okay, you have to think about where is this going to happen. Now, Agile can make this a real challenge because how do we integrate the creation of these tests for functionality that was built in a previous iteration into that iteration, because everybody's attention is supposed to be focused on that particular iteration, right? Think about the agenda of the daily stand-up meeting. What did I do yesterday? What am I going to try to get done today? What's in my way? Right? Super, super tactical, minute focus on the goals of today. You start talking about, well, I'm building automated tests for some functionality that we created 6 months ago, or I'm maintaining automated tests for some functionality we built 6 months ago. People are going to be like, how is that connected to the goal of this particular iteration? So a lot of my clients have separated that out, and the people that are building these scripts that are used by the testers within the sprint teams are in a separate team. That's their job. Again, here I'm like spouting agile heresy, right? And I can just like imagine an agile purist going, "That's not agile, you can't have people." Well, my clients do, and it works for them. You know what? So what do you want? Theory or practice? So we want to have these scripts. These scripts need to be usable by the testers. When they run the testers, they can then look at, what are these anomalies, these discrepancies between actual and expected results. Now, you do have to expect that there is going to be a higher false positive rate with automation. Okay? Because, we're going to try to create the automated tests so that they can run without intervention. But there are going to be situations where they get a mismatch between the actual and expected result. They get an anomaly, and the test can't really be sure, so it's just going to log the mismatch. You're going to have to look at that. So you have to keep that in mind. People sometimes automate, and they're like, "Hey, look at this automated tool. It's like a magic wand. I'm just going to hit my testing problems, ching, and it's going to go away." No. There's going to be effort in analyzing the results, and that's not necessarily something that can be sloughed off to the most junior members of your team. So you have to build some time into that. Also, the people that have built the scripts have to be ready to intervene in that process. So it can't just be the people build the scripts and they go off and they build more scripts and they don't support the effort of using the scripts. This is something that I saw kill a test automation project very recently. And they basically got these really smart guys, and they were really smart guys, and they were really experienced guys, and they went off and they built this automated test system, and it was whiz-bang again, the dancing brooms and mops, but they just threw it over the transom to the teams and said, "Here you go, gift of the gods. Go automate all of your tests with this." And the management said, "Yay, we got the gift of the gods, go automate all the tests." And then people went off and they're like, "How do I use this to automate the tests?" Now, what you might think would happen is that people would say, no, you've got to explain to us how to use this. Oh, genius that gave us this gift of the gods, right? Insist. And some of them tried that, and the response they got was, "Go away, you bother me. I've got more important things to do than explain the obvious to you," because to them, having built this system, it was obvious to them how to use it, right? But it wasn't to the people that it was given to. And so they tried to use it, and almost all of them failed. And when they failed, they're just like, "We're not going to make a big deal out of the fact that we failed, because that might mean that we look stupid. And we don't want to look stupid. Management doesn't like to have stupid people around, and they usually make them go away. So we're just going to silently not do the automation, and so nobody's using the tool." Right? And this happens all the time with my clients. It's just like, where good tools go to die, right? Into broader use, right? So you got to have a strategy for that. How are you going to roll this thing out? How are you going to support it? Okay? So automation without a strategy ain't much of a strategy. Okay, so let's talk about the case studies here. Just a quick time check. I think I've got about 20 minutes, 30 minutes left. Is that about right? Yeah? Okay. I can't see a clock here, so I apologize for that. So here's one of my clients that builds a system that does security management. Okay, so one of the challenges that you have in a data center is you've got lots and lots of systems in the data center. And if you've been in business for a while, you've got all kinds of systems. You got systems that, dinosaurs like me, when I was at UCLA getting my computer science degree in the 1980s, that we used, right? I came in, the people who were writing a couple classes before me, they were still using punch cards. Seriously, we'd like taken a big step forward. We were like, "Oh no, it's not punch cards, it's green screens," right? And you might say, "Oh, then surely all of that stuff's gone." Nope. I saw a statistic that about half of mission critical transactions in the world get processed by COBOL. Really, COBOL, it's still out there. So, you know, these organizations that have these large, diverse data centers, they have a challenge. It says, like, we need to be able to manage the accounts and the account permissions on all of these dozens, hundreds, maybe thousands of different systems that are in our data centers. How are we going to do that? So that's the solution that this piece of software provides, which is that there are what they call agents that run on each of these servers. And the agent is able to do things like add accounts, change the permissions on the accounts, delete the accounts, basically manage the accounts from a security point of view. Okay? And that agent, or agents, are then connected to a central workstation that administrates those agents and provides a single unified view of which accounts are where and what permissions do they have. Pretty cool, huh? Pretty good idea, yeah? Rather than, you know, it's a system administrator's got to scurry around and try to administer everything. Now you might think, well, you know, what's so special about that? Hey, I've got Active Directory. Well, yeah, that's great if you've got nothing but Microsoft. But again, here I'm talking about a technologically heterogeneous environment that includes hardware that has its origins in the 1960s in some cases, or before, IBM mainframes. So, how did we build our test system for that? We could have said, well, you know, there's a graphical user interface on that central workstation. We're going to drive everything through the graphical user interface. We could have done that. That would have been galactically stupid to have done that, but we could have done that. But instead we said, no. The whole way that the system that we're testing works is that we've got software communicating to other pieces of software, the central workstation to the agents, in this case, via network services, right? So we're going to test the same way. We're going to test through that same approach. Now, I'm assuming that yeah, okay, it's kind of interesting. See through the screen back here, so, all right. So on the, from your perspective, the agent, the thing marked agent is on the right-hand side or the left-hand side? Right-hand side? Okay. Sorry, I got a little fun house of mirrors thing going on there. It's like, did I flip it around once or twice? So the agent, that's the part of the system under test, and it shows a single one there, but remember that while any one test is testing a single agent, there's actually dozens and dozens of them, right, in a real deployed system. And there's that thing IRMA, which I forget what IRMA stands for, but IRMA is basically the workstation that you use to interact with the agents. And there is also a database that all of the information about the state of the security and accounts on all of the different servers is in. Okay? So that's the system under test. Now, we, through our tool, we built a communication piece using a scripting language called TCL, which if you're not familiar with that, I'd encourage you to check it out. It's a really cool little piece of technology, very scalable. And so that scrcom.tcl is a script, and what that script does is it knows how to talk to IRMA, and it knows how to get data to and from the database. That's all it does. Okay? Now you might say, why is that all it does? Well, because that is a single, cohesive task, right? And if the way that IRMA talks to the world changes, or the way that the enterprise server database looks changes, the only thing that we have to change is that one script, right? And that script, that scrcom.tcl, presents a standard interface now to all of the other scripts that we're going to write that are each going to implement one of these keywords. Okay, you see the kind of the middle there, scradduser.tcl? That's the script that knows how to do one thing, add a user. Okay? And it expresses that add user in a particular format, and it sends that information to the scrcom.tcl script. And then it, scrcom.tcl, communicates either with IRMA as if it were an agent. This case is basically mimicking an agent, or it communicates directly with the database. It actually inserts something into the database. Okay? And then that information gets passed on further to the agent. You see how we've basically walled everything off there? Now, if the way that the user is added changes, what do I have to change? scradd underscore user.tcl. That's it. You see that? So that's how we're getting maintainability. Anything can change, and that's fine. You change it, I know exactly where that change is, what is affected by that change. I know the script that's affected by that change, I go in and I maintain that. Now, you see that there's a couple, there's add user and there's delete user that are defined, but in general, any keyword, any sort of operation that the agent can carry out, any sort of operation we will want to carry out against the database, that's something we just write a keyword, write it and define how it works, and then the script folks, the SDETs, say, okay, I'm going to implement a TCL, also sometimes called tickle, script that implements that particular thing. And it just does that one thing, remember. This is really key, that each one of these scripts does exactly one thing. As soon as you get to the scripts that are like it's doing 2 or 3 things, now you're going to have a problem. You've got one thing, okay? Now, where are these scripts that are implementing the keywords getting their instructions from? Are they communicating directly with the test cases? Absolutely not, because, again, we want to separate that. So we have a separate script, the scrmaster.tcl. This is the execution engine. Okay, this is the big kahuna, as we state, that drives everything. Okay? And what the scrmaster script does is it reads the test case file. That's the test case .case files, reads those are text files, and each one of those is associated with 2 other files. Each test case is associated with 2 other files, an input file which contains all of the inputs that are going to be used by the test case, and an expect file which contains the outputs that we expect to be produced, which are mostly like return codes and so forth, because remember, we're talking over a network services interface here. Now, does the master script know how to parse these files? Absolutely not, because again, that's a separate thing. Okay? The master script, the scr_master.tcl, is like the conductor of the orchestra. It's not playing any instrument by itself. It does not know how to parse those scripts, but it knows who to send them to parse them, and that's the scr_tc_parse.tcl script. So it reads those tests and their inputs and expected results. It passes all of that raw stuff up to the parser script, and the parser script comes back and says, here you go, here's your package of stuff to do. Okay, why? Because if we discovered, oh, we got to change the syntax of the .case files or the .input files or the .expect files, cool, no problem. Again, I only have one thing that I have to change in order to do that. That's scr_tc_parse. See that? Doesn't affect the execution engine. It doesn't affect the master. So the master knows how to select the appropriate keyword script to call, add user, delete user, what have you. It passes all that information off. That thing then passes the information formatted appropriately to whatever command it's going to invoke to the scrcom.tcl, which then communicates with the system under test, and then the results come back through that same chain, go back to scrmaster. What does scrmaster do again then? Remember, it does one thing. So what it does is says, hey, I've got test results. You, scrlogger.tcl, log those for me. And that way, if we want to change the way the log files look, is we're like, hey, you know what? We think the timestamp would be better if it included, you know, not just the second on the seconds where the test was run, but down to the milliseconds. So, you know, 17.253 milliseconds. We want to have that precision of logging of when the test is run. What do I have to change? Do I have to change SCR master? No, I don't have to change SCR master. I just change SCR logger. You see that? So highly, highly maintainable. Yeah? Any change is going to affect one thing. It's not going to break a whole bunch of stuff. Now, the .case, .input, and .expect files, those are all files that are created by the testers, the business-oriented testers, okay? And then the other stuff there in the test system, that's all created by the SDEVs. And we built a nice little front end that fit on this that actually would automatically generate, based on inputs from the testers, the .case, the .input, and the .expect files. So eventually, they didn't even have to understand the syntax of how those XML files was built. All right. So let's look at another one here. This is a data analytics and extract tool that is able to talk to a very diverse set of databases. SQL databases, non-SQL databases, ISAMs, if any of you remember that, flat files, tree-structured databases, okay? And it has a graphical user interface, which we could have automated through. But again, that wouldn't have been smart. It also had a command line interface that you could talk to that would access the data layer, and we could use, they weren't pure English, but they were very much English-like grammar to, with this program, query the database and pull data out of it. And while the graphical user interface would change, the command line interface was very stable. And we could use open source scripting languages, pass command line commands directly into it. Okay? So we automated through the command line. And so there's the architecture for that particular system. You see the system under test there on the that side, right? Shown in gray. You see that? So you got the analytics tool, and then it uses a module called file read to either go out and directly read the data or to communicate to a database through an API. Now we are just going to talk to it through that command line interface that allows us to poke and prod on the system under test. Okay. So we had thousands of test cases that we built, and these are text format test cases. And we have a parser, so that's a part of our test system, so similar to before, right? And the parser then says to the data read logic in the test system, hey, go ask for this particular data. Go ask for this report, go run this query, and then it comes back. The result comes back, okay? At that point, the result is compared to the expected result. Now, remember, we're running across a lot of different databases that run on a lot of different operating systems. So while we had the same data from a logical point of view represented in all 20 or so databases that we supported, it was possible to get somewhat different, though different in terms of things that didn't affect the meaning of the data, somewhat different results back. So we allowed for testing for, is the expected result found at the database level? Is it unique to this database? If not, is it found at the operating system level? Is it unique to the operating system? Otherwise, it should be generic. And so most of the time, about 95% of the time, we were able to compare against the generic expected result. Okay? But if there was an expected result that was like, you know, for this particular version of C tree, for example, we get this result that looks a little bit different. We were able to handle that. Now, we had a smart comparator that we wrote, and this was the only thing that was not written in scripting languages. It's actually written in C for reasons of speed, okay? And the smart comparator would allow us to do things like deal with date fields. So we could say, look, this field in this report is a date field, and make sure that it's properly formatted, right, that it matches the pattern of month, day, year, day, month, year, however it should be, but don't check the specific values. And in some cases, you could even get records that would come back in different order because you have what was called non-deterministic sort orders that would result in the same query resulting in different orders of the data being presented from one database to another. We were able to handle that too. So that was the logic in the smart comparator. And that was probably the most sophisticated part of this thing. So the blue stuff there, you know, this is the stuff that the test analysts, the business-oriented testers build. The white thing, the white shaded items, parser, data read logic, et cetera, that's what the SDETs built. Again, each script, each program does one thing, and highly maintainable. Okay, so I've shared with you some stories here, many of them sad stories, about automation gone awry, okay? And the generally accepted figure, though nobody's, as far as I know, has done a actual study of this, the general accepted figure is about 50% or more of test automation efforts fail. And that's certainly consistent with my experience as a consultant. I see a lot of tears, a lot of things that people started and they had high hopes for and it didn't work out. And a lot of times that's been exacerbated by the fact that they tried to go through the graphical user interface. But that's starting to change now. I'm seeing a lot less of that with our clients and a lot more of testing through other kinds of interfaces. So maybe after 20 plus years of being fixated on automating through a graphical user interface, we're now letting the sun go down on that, saying, I don't think we're going to focus on that. Now, we don't want to, as the saying goes, throw out the baby with the bathwater, okay? Keyword-driven testing is a great idea. It's a best practice in automation, but don't associate that with GUI testing. It doesn't have to be through a GUI. It can be through any accessible layer. I showed you service layers. I showed you data layer. Whatever way you've got to get at the application, that's fine. You can automate through that. It doesn't tell you everything, but then again, neither does automating through a graphical user interface. There's a lot of stuff going on in the software that's not visible or accessible through the graphical user interface either. Most of what I've just been talking about, the two case studies, open source tools. Okay? In fact, both of the case studies are our tool license budget for both of them, goose egg, 0. Okay? There's a lot of free stuff out there, so take advantage of it. And get away from automating the graphical user interface if you possibly can. Now, I sometimes like to use strange words in presentations. I try to avoid it, but sometimes I'm tempted. And so I've always kind of wondered, will I ever be able to use this magical English word, defenestrate? Anybody know what it means to defenestrate someone or something? Throw it out a window, that's right. Very good. Yes, apparently fenestra is like the Latin word for window. And so defenestrate is a Latin root word meaning to throw something out of a window, generally an upper story window. And you just have to wonder how English came to have a specific word for that, right? Is that actually so common, right? But it actually perfectly fits here because graphical user interfaces, they got windows, okay? So it is time to defenestrate your automated tests, throw them out of the windows, get them down to the data layers and the service layers, and make them more maintainable. Okay, so I know that was a tough joke to pull on a, an audience that doesn't have English maybe as their first language, but I hope you get some appreciation out of it. Defenestrate your automated tests. All right, great. Do we have time for questions?
I think just about one or two maybe.
One
so
or
let
two?
me just very quickly switch the box. But before I do that, a big hand for Rex Black.
Thank you very much. Thank you. Thank you. It was fun.
Okay, the magic has happened, I can see, I think.
It worked?
I think so.
All right.
Okay, let me try this. Unknown words in English. Don't GUI and non-GUI based tests actually test different things? For example, how can you test web app behavior on different browsers without GUI-based tests?
Okay, excellent question, and yes, absolutely that's true. As I said, you're testing different parts of the application. To go back to defenestration in Windows, you can think of each interface, graphical user interface, network services, data layer, API, et cetera. Each interface provides you with a different window into what's going on in the software. Okay? And there might be some things that are going on in the software, such as the example cited here, that are only visible through that window, that vantage point of the graphical user interface. Okay? But there's all sorts of business logic that can be accessed through other avenues. Okay? So, absolutely, test what you have to test through the interface that is best suited to test that. But just understand that if you have to test something through a graphical user interface, it's going to be a heavier lift to automate those tests than something that you would test through a different interface. So you may decide, you know what, we're gonna do our validation manually through the graphical user interface, and we're going to pick up these kinds of differences in behaviors and so forth as part of that. But the bulk of our business logic testing, we're going to focus on other interfaces. I hope that answered the question.
Should we have just one more?
One more is fine.
Okay, as voted by the users, a question to changing GUIs that break tests. What do you think about the idea that a developer which change GUI should fix tests? That's great. We refer to this in the United States as the Pottery Barn rule. Yeah, I don't think you guys have Pottery Barn here, do you? But you have pottery, right? So Pottery Barn is a store that sells pottery, and there's a big sign when you go in. It's the Pottery Barn rule. This is, you broke it, you own it. Okay? You knock the pottery off the shelf, it hits the ground and goes bang into a million pieces. You broke it, you own it. You get to take home the wreckage, right? That's the same rule that's being proposed here. You say to the developer, you change this thing, it breaks the test, you have to fix them. Okay, that's a classic example of transference of a project risk. And my experience with transference of a project risk is it don't work. Because you could say that in theory, and the developers could agree to it in theory. Then the developer's going to say, but boss, I've got real honest-to-God functionality to write that's going to deliver value to our customers. Do you seriously want me to go in and try to maintain a bunch of test scripts that I don't understand? And boss is going to say, hell no, I don't want you doing that. You go stick to your knitting and write new functionality. Meanwhile, Mr. Estet, you clean up the broken pottery, right? So I think it's just one of these things where it sounds great in theory, but in practice what I've seen, again, with most attempts to transfer test-related project risks onto other entities, they simply will not accept it. So we have to find a way of working around the fact that stuff's going to change. I love that question. Thank you very much. I think that's all we've got time for. So
Great.
This was called 2 Case Studies in Non-GUI Test Automation. Do it properly this time. Rex Black, ladies and gentlemen.
Thank you. Thanks a lot. Thank you.